That felt like an epitaph, Geoffrey, more than anything else. But yes, I think we're a number of folk surprised and were in some trepidation when I became Vice-Chancellor at Strathclyde University, including myself. Anyway, ladies and gentlemen, it's a real privilege for me to have the opportunity to deliver the Peter Wilson lecture this evening. When Stuart Munro sent me the list of distinguished speakers that you've had in the past, I shivered to see all these very significant scientists, and clearly you're slumming it this year, inviting an engineer to come along to speak to you. But as a great friend of mine who would have been known to some of you, David Tedford, used to say, you can always tell an engineer, just not very much. So with that caveat, I'll now begin my talk. And of course, energy is an enormous subject, so I want to try and take you down through several paths that will touch on context for Scotland and an international scene, but also look at the opportunities in Scotland from our science base through to the opportunities for wealth creation, and just as much an important issue for me, I know for a number of others in the audience, it's about the inspiration of our young people in Scotland to pursue an energy-relevant career. But let's look at the context first of all. And these are numbers I'm sure you're all very familiar with in terms of where we are going, in terms of these ambitious targets that have been announced and driven by our Scottish Government. We will be at 31% of our electrical energy sources provided by renewables by 2011, target for 50% of electrical power supplied by renewables by 2020, 20% of all energy in that time frame, 42% carbon reduction by 2020, again interesting numbers, and a stretch target of 80% by 2050. Important, I think this distinguishes Scotland. It gives us an opportunity to capitalise on our opportunities, but also I think it distinguishes ourselves on the international scene. And I smiled. The past 2 weeks I received two gifts, and I'd suggested I wanted one. Our First Minister, when he was at Copenhagen in December, took with him a large number of gifts, and one I thought was pretty poignant, and it was this. And when someone saw me taking this out of the poly bag that I brought it in from Glasgow, they were wondering exactly what I was doing. It was this bottle of whisky. And the bottle of whisky was actually produced by Edrington Group. And I'll let you have a look at it. It's a prized possession of mine, although I have to say it was the chap that distilled it that gave it to me as a gift, and another one came in just last week. I didn't turn it away, I have to say, and I'm just scared to drink it. But what it is, it's the 2020 whisky. It's 42% proof, which I think is a nice touch, but I think it also allows Obama, I'm told reliably, has a bottle of this whisky. I suspect he's been drinking from over the past few weeks. But again, placing Scotland's traditional industry, including whisky, in the context of what is a globally challenging opportunity for us, I think is a nice touch, and it also allows Scotland to play to its strengths. But that aside, I'll leave this whisky bottle here because, as I understand, Duncan and others are going to be giving me a hard time at the questions, so I may have a glass as we go. Here's an interesting diagram for you, produced by a good friend of mine who sadly is no longer around, Bert Whittington from Edinburgh University, where when he was in secondment to Scottish Government, he produced this diagram, which is still as relevant now as it was then. And if you look in the left-hand slide, in 2000, these blocks are showing the distribution of conventional power stations. Green nuclear with Hunterston down on the left-hand side here, Torness over on the east coast, Cockenzie, Longannet, Peterhead up towards Aberdeen, and then, of course, at that time, Dounreay. Winding forward in terms of the planned lifetimes for these stations, you can see that by 2020, as it happens now, coincident with our government's ambitious stretch targets, what is left without any further plant lifetime extension or further investments, for example, in the Hunterston Sea, which is not close at the moment, would be Peterhead and Torness. Goes forward to 2030. There are none. Now, that's an interesting backdrop when we realise just exactly where we are in terms of trying to capitalise on our renewables targets. But that's an important backdrop, and it's something, and with all due respect, I try to keep on reminding our political leaders of in Scotland that renewables is an extremely important part of our future, but in the context of a secure, reliable, mixed energy base. I think that's the important way forward, and we'll touch on that as we go forward. So there are a number of key energy and industry sectors here in Scotland. Renewables we know about, and I'll say a little bit more about shortly. Power generation generally, in terms of coal, gas, and indeed nuclear. And oil and gas is important. I mean, over the past couple of months, I've been seeing quite a lot of colleagues from Shell and BP, and they're playing, I think, a very constructive part in trying to translate their own know-how in offshore technologies to try and help realise the vision of Scotland being a real, as we've heard before, a green powerhouse for Europe. And indeed, another phrase that's coined that came out of Aberdeen University, but our First Minister coins it about the Pentland Firth being the Saudi Arabia of marine energy for Scotland. Well, in all of that, that's important, but oil and gas is going to be around for at least another generation, and we must remember that much of our energy still comes from hydrocarbons, and we have to make sure that we understand that, and putting alongside carbon capture and sequestration alongside the hydrocarbon industry, I think, is an important way forward for us. And of course, last but not least, these are the sources, these are the primary fuel sources and the primary energy conversion sources that we're used to. But I always smell, as an electrical engineer, we often forget that between the production of electrical energy in particular and its use is the means to transport electrical energy, and grid is a big issue, and I will touch on that because it's going to be one of the major blockages to realising our potential if we're not careful. So in renewable technologies, the usual bundle where Scotland can be particularly effective is onshore and offshore wind, and again I'll broaden out that in a moment or two. Marine technologies, a real opportunity that allows us to try and capitalise on the science base, the potential industry growth, and the translation from traditional industries to support this. Professor Anne Glover's here tonight. She is chairman of the main steering board for the Saltire Prize, which again, although some difficulties in it coming into being, again shows a great ambition that Scotland is setting its stall out on the international stage to say, look, we wish to develop these technologies and have them deployed in Scotland, but we want to be open enough and confident enough to bring international industries and innovators and academics to try and test their ideas here in Scottish waters. With a £10 million prize of public money, I think that's an important step forward, and it wasn't without its difficulties, but now it's there. I think it's a great challenge both nationally and internationally. Hydrogen and fuel cells, we have great capability. I'll say more about that. St Andrews University in particular, through John Irvine and Peter Bruce, super scientists and able to translate their know-how into generation technologies, and increasingly now biofuels and biomass. And again, I'll say a little bit about that. Transmission and distribution, I'll say not much more at this stage, but let me just remind you that the grid that we have in the UK really was conceived of in 1926 as a result of the Weir Act, where Weir himself, a Scotsman, said that in order to realise our potential and to have secure supplies, we needed a gridiron of electrical connection, which is a beautiful language, but it encapsulates what is now something we're very familiar with. But the infrastructure we have around us is now of the order of 60 to 70 years old and getting close to its capacity limits, and indeed some of the technical challenges of connecting renewables to these networks are taking it to the limits of its technical capability. So smart grid is a term that's been coined, and if you go to a conference in networks, you'll find with 10 presentations, you get about 10 different definitions of what smart grid is, from smart meters to the deployment of intelligent agents to get to data processed. The truth of the matter is it's about a major reinvestment in the infrastructure based on power electronics to give us reconfigurable networks, and in times allowing our networks to reconfigure into autonomous power islands, which is dead set against the grid codes just now, but it's exactly what we need to do if we're going to realise our potential. Generation we've talked about. I will say a little bit more about carbon capture and storage. World-leading capability in Scotland. Stuart Hazeldine and his team in Edinburgh, with support from other academics, absolutely at the forefront internationally. Companies like Scottish Power, to a lesser extent at the moment, Scottish and Southern Energy, Doosan Babcock and Renfrew over on the west coast. Genuine opportunity now for Scotland not only to be a low-carbon country, impacting positively on society, but creating wealth, but also to give us a real platform for international leadership. And again, and I make no apologies for bringing back oil and gas, there is a real opportunity for us to continue the effectiveness of subsea technologies and looking at new drilling technologies. The smart platform, as our colleagues in the oil industry will have it, are ways of improving yield, and of course there's a part to play there in terms of carbon capture and storage, and maybe using CO2 down into these wells can also help us release additional hydrocarbons. So with that, let's remind ourselves of the actual extent of renewable potential. Scotland has around 25% of Europe's wind energy resource. I'll show you some graphs just to confirm why it's windy and wet in some of the places we go for our holidays. And having been at Loch Fyne over the weekend, I have to tell you, I went there with a small cold. I've come back with a flu, but never mind. Scotland's estimated to have about 10% of Europe's wave resource and 25% of its tidal resource. So in aggregate, around 40% of the European renewable resource. And you can see in the small table there, onshore wind, in terms of the available sites and those with the best yield, something approaching 12 gigawatts. Context there, the peak demand in Scotland is around 6 gigawatts. So onshore potential about 12, offshore 25. The whole benefit of better wind flow, more predictable wind flow, 25 gigawatts around our shores, and tidal about 10 gigawatts, and wave 14 gigawatts. There's some numbers that are bandied about in terms of the Pentland Firth having a potential of about 25 gigawatts, but for some of you may be involved in the new pooling consortium masts around marine science and technology. We need to start looking at the hydrodynamics and the modelling of flows, just to understand A, the real potential, and B, the reality of how we can extract that without having too much wrecked prototype equipment on the shores in the north of Scotland. But nonetheless, the potential is significant, and this is exploitable, we trust, or at least a good majority of it, over the next 10 to 15 years. And even getting 20% of that total would be a massive step forward in Scotland, increasing its capability. You can see from the colour diagrams here in terms of the wind resource, you can see that Scotland is blessed. Here on the left-hand side, across Scotland and the west coast of Ireland, and if you then extend that to look at offshore, again, you can see exactly the prospects of us, harvesting the offshore wind there. I mean, there are lots of planning issues there around Crown Estates, and indeed some of the releases on particular sites. But nonetheless, and I'll say a little bit shortly before we move on to other subjects, the integration of planning, investment, and the opportunity to keep wealth and job creation in Scotland, I think, is fundamental here. But with a will, we can get there. We're now very familiar with onshore wind farms. We pass them more or less every day. This is a site actually not far from where I live. I live about 5 miles from the Whiteley wind farm near Glasgow. It's up in the Fenwick Moors. But 320 megawatts of total generation output. That's peak output, and about 140 turbines when complete. And at the moment, it's Europe's largest inland wind farm. And there's a new Clyde development underway. I think it was announced about Easter last year, which will be approaching about 600 megawatts. So again, we're starting to see this. There are environmental issues there in terms of impact, and of course there's the whole issue about looking at the impact on flora and fauna. But nonetheless, this is becoming, shall we say, acceptable, more accepted, but of course there's a limit in the capacity in which we can exploit here, not only in terms of the sites, but in terms of the grid, and I'll come back to that again. Another real opportunity for Scotland to innovate is in now offshore technologies. This is a really nice photograph of the Beatrice demonstration site. This was a project, I was involved in some of the electrical design for these systems. These are two 5 megawatt machines. They're in really the world's first deep offshore wind installation. It's sitting in about 45 to 50 metres of water. There were issues about getting grid connection on shore, so as a consequence the power output from these machines is actually going to that platform in the distance there. But the thoughts here of Talisman Energy, Canadian oil and gas company working with Scottish and Southern, EDF, and a number of academic groups, including my own, was let's look at the prospects of maybe 250 of these turbines in that space. Then we start to see the issue of scale, but But if we are going to get as much of that 25 gigawatts of offshore wind, we need to start thinking about scale, and there's a European dimension here that's going to be driving this. Let's look at the wave and tidal resource again. Looking at that flow across the Atlantic, you can see again tremendously energetic waves. Coming in directly into the west coast, but moving up through Orkney and Shetland. And you can see again on the tidal power on the right-hand side, very significant intensity there. So potential is very significant. We need to continue to model the resource and also to optimise location. But through that, we need to translate our science and engineering research base to prototypes, demonstration, deployment, and then full commercial exploitation. And one centre, I think, it's setting the pace, as it were, that Scotland is to replicate, is EMEC, the European Marine Energy Centre up in Orkney. It's a genuine jewel in our crown, and it's allowing us to genuinely map out our opportunity to take our research know-how and getting this into devices. This idea of going from research and development to demonstration and deployment is something that really needs to harness the Scottish Government's thinking and indeed industrial thinking. For those of you that have been involved in product development before, I know several of you have been, this notion of technology readiness levels, typically when ideas, particularly in large engineering projects, leave the academic laboratories, it's normally about technology readiness levels 3 or 4, and you need to get to 9 before you've got a supportable set of products. And that gap between what we need to do as a research community to support industry, it really needs to be bridged. And one way of doing it is having highly professional, well-equipped demonstration laboratories. And I jointly chair the Energy Advisory Board with Mr Salmond, and there's a proposal now, and it's these things are in the public domain anyway, that we're going to try and create what we're calling a working title, the Scottish National Energy Laboratory, which will be EMEC, the Advanced Forming Research Centre, the new Power Network Demonstration Centre, prospectively, and it'll be interesting if we talk about in questions, the Aberdeen Harbour offshore wind demonstration site. I'd like to see that go ahead. The Hydrogen House, the laboratories in Edinburgh University, for example, for tidal, and really present ourselves as an innovation hub for the world, where you can not only conceive of energy ideas, but you can get through these technology readiness levels to products that are ready to roll and can support the growth of industry and the creation of jobs. So EMEC, again, is awash, again, excuse the pun, with devices. So here, for example, the wave devices that are currently under, and it's hard to keep up just now because there are about 12 to 14 devices just now on there. The aquamarine power device that went into the water, I think, in October, November, AWS, OPT, the Polymers wave power device. Again, these sites are not only testing in live areas of scale, but also giving an opportunity to connect to the grid. And that's something interesting going on up in Orkney as well. We have our first deployment of smart grid technology in Europe up there that's allowing us to take advantage of distribution network capacity that would normally be a limit to connecting these devices. And in tidal devices, again, a whole range of innovative designs. Some of them free moored, but in the tidal flow. Some of them directly moored onto the base and firmly anchored. But again, a whole range of technologies. And we have no. They're all prospects. There are no distinct winners yet. A number of these have expressed interest in the Saltire Prize, which is great. But again, because of that facility, we're translating know-how out of the universities to devices, and we're also attracting innovative SMEs as well as large-scale companies. And they always say follow the money, and you should have a look at the number of large-scale companies that are now taking a stake in new marine technology companies, including that is marine energy technology companies, Rolls-Royce, Scottish and Southern, Scottish Power, the oil and gas companies. So I think that's a good sign for the future. I think I'd be uncomfortable if I wasn't saying a little bit tonight about the Energy Technology Partnership. This is one of the pooling entities that sits within the engineering pool in Scotland. The ETP, which I'm absolutely privileged to chair, and direct with a number of other colleagues from across Scotland, I think it's really differentiating Scotland in terms of the way that we're behaving that we were bringing multidisciplinary research skills from science, engineering, and indeed increasingly, which has been an interesting journey for me as an individual, the social sciences that need to impact on the translation of energy know-how to impacting on citizens, impacting on the acceptability and the sustainability of what we're doing. So the ETP is made up, and this list of crests will be growing. There'll be one or two other crests on there by the end of May. But it's the main big research-led partners just now are Strathclyde, Heriot-Watt, Edinburgh, St Andrews and Aberdeen, but our other colleagues are playing an increasing part. This is the engineering pool. Scott Ken, through the University of St Andrews, is bringing their know-how on hydrogen and energy storage, and we've got very good engagement from our colleagues here from a number of the other public sector and advisory groups. So that partnership was born out of opportunity when we tried to pursue the Energy Technology Institute hub a couple of years ago, but now what we're doing is in Scotland we have the largest number of ETI Energy Technology Institute projects in place. Our key technology areas, and I'm going to just accelerate through some of this so we can get to one or two of the main themes for tonight. Wind energy, we have a doctoral training centre at Strathclyde, which was greatly enhanced by the ETP's existence. Marine energy, undoubtedly, world-leading capability in Edinburgh University, and again that has attracted a lot of supergen funding, EPSRC that is, power systems and networks. Again, Strathclyde strong here. Bioenergy increasingly with Aberdeen and Glasgow University, particularly from the biological sciences, and the synthetic biology is an opportunity now that we're seeking to pursue with SALSA, with Mike Tyers and the Life Sciences Alliance. Built environment, surprisingly large number of groups there that we're now trying to support to come together to create the critical mass in Aberdeen, Heriot-Watt, Strathclyde, Napier, where we're looking now, of course, not only at the supply side, and that's a point I want to make to you later on in this talk, that we're often drawn to the sources, the fuels, the infrastructure, but of course, and I think the European Union is importantly flagging up to us, that if we get the demand side in balance, that helps us a great deal by reducing demand, being more effective in our use of energy. Energy conversion and storage. Induction machines are one of the most common forms of energy conversion. They're in washing machines, they're in most manufacturing plant. But just getting about 5 to 10% more efficient energy conversion on an induction machine could give us terawatt hours of energy savings internationally. And so we need to think about the energy conversion. Oil and gas, I've mentioned to you, and CCS. And as I've said to you, and I'm not paying lip service to it, increasingly important for me is the governance, regulation, law and economics that goes with the whole energy scene. And so we're now working with colleagues in Dundee, St Andrews, and other parts of the ETP to try and get that translational set of social sciences to make sure that what we're doing as engineering and science researchers has a big impact. So, wind energy. The interesting thing for me is that the wind energy will go from micro to macro. There's still this pursuit of maybe getting effective building integrated renewables, where we may go from small scale 1 to 2 kilowatt wind turbines. Interestingly, and with in some trepidation, about 5 years ago, myself and a colleague, Joe Clark at Strathclyde, managed to persuade the Charles Rennie Mackintosh Foundation to deploy a number of wind turbines on the Lighthouse building in Glasgow, and they were not too comfortable with that idea, but we managed to, working with some manufacturers, get the aesthetics just right, and we have deployed on their ducted wind turbines that actually meld into the fascia very, very effectively, each giving about 1.5 kilowatts, and of which there are about 8. So there are ways of doing that, but to get the big replacements, remember a Longanic power station is about 1,600 megawatts. So to get that sort of replacement or displacement, we must be talking about also wind turbines of scale. So just now, the largest device that's commercially available is about 5 megawatts, and there's now a push from a number of the big international manufacturers to go larger. And the number that's on the horizon just now is 10 megawatts, but that that's big, and I'll give you a sense of scale just in a moment. So we need to look at generators design, power electronics, and the whole notion of wind resource assessment. And again, Scotland's well placed to lead in this. So again, we need to remember, there's the far end there. That 10 megawatts is coming down the next couple of years, but you get a sense of the blading here on a 5 megawatt device, and in terms of that 120 metre pylon, you're talking effectively what's a Boeing 747 in span on these blades. These are big bits of equipment, and again, sad person that I was. Whilst I was at Lochfine on Saturday and Sunday, I was down at the Skycon factory down at Machrihanish to go and look at the blades. What a sad individual I am. But and even worse than that, I took my 12-year-old son who wanted to go and play golf. But we went to look at the blades for an hour before we went to Machrihanish golf course. But these are big, and so you start to think, well, if we are going to really capitalise on the potential, and we are going to go to 10 megawatts, then increasingly offshore is the way that we're pragmatically going to get access to that. So marine energy, again, predominantly a set of skills and capabilities from our colleagues in Edinburgh University. Now, whilst I'm making Scottish references here, I think it's important that I stress to you, this is a Scottish capability in the context of an international research community. So I think all of the ETP partners could, give you the comfort that we're working in the context of leadership and partnership in the international domain. So the resource analysis is important there, but the whole idea of, into the second bottom bullet point here, the whole civil engineering and materials piece of moorings and seabed fixings. So the Telford Institute of our civil engineering colleagues are playing a significant part in making sure that the structures and the design and the infrastructure that we create is absolutely right. So the melding here of civil engineering, electrical engineering, materials, the marine technology, as well as the computation and mathematical modelling. Just a fantastic multidisciplinary opportunity that Scotland is starting to push on. One of the challenges here, and just simply because of where we are in the evolution of marine technology, and it's by and large, I would stress, equivalent to where the wind industry was maybe about 15 years ago would be about right. And what we have to do is to ensure as far as we possibly can that Scotland keeps a good hold on the opportunity to keep the scientific leadership, but also to translate that to economic development. These are some slides from colleagues in Edinburgh University, and you can see some of the, from modelling to devices, some of the data visualisation and the animation here as to what the Polymers device would have looked like, both in terms of a digital environment, then here in terms of the test wave tanks at Edinburgh, and of course ultimately now to the realisation of the device. And I'm sure all of you have seen this. It's becoming quite an iconic shape, the Polymers device. But if I give you an idea just of the scale of this, and also the energy and the potential violence out there, just seeing these things in the water gives you a scale of the fantastic engineering, but also the scale of the environmental challenge of actually putting these devices into the water. I mean, the Polymers device is based on basically pressurisation and pumping of hydraulic fluid in reaction to the wave motion around these joints, and the hydraulic fluid eventually makes its way to a set of turbines, which then drives an electrical generator, and then there's the power takeoff. But again, you just get the sense of scale, and we need for these devices arrays of potentially many dozens of these. But again, from an engineering perspective, beautiful, elegant, and really well designed. And let me see if I can come out of that now. So beautiful, I needed to show you that again. So let me see if I can get to the next slide. Okay, electrical systems. And again, I won't major on this. My pet subject. I'll be here all night. But the whole idea of what's interesting for me, a lot of the basic givens of 50 hertz and 240 volts at the socket and 3-phase are all born out of the way that electrical systems and machinery developed. Just the pragmatism of a 3-phase winding onto a stator defined originally. That's why we went to 3-phase. The 50 hertz was just how fast we could get a prime mover to rotate that rotor inside the stator that gave us that 50 hertz in the UK and Europe, and 60 hertz as it happens in the States. But now, because of the advent of technologies such as power electronics, which is basically transistors for big boys, that can translate and switch and change the direction of current and manage voltage. Power electronics can allow us to have a multi-variable frequency power supply. It can completely change the way in which we deliver and transmit electrical energy. The potential for high voltage DC systems is with us now in a very much more affordable way. The prospect of superconductivity is an interesting one in niche applications, but the big push these days is in smart grid, and again, lots of definitions there. What's more importantly is what it means. It means that we can move away from the large-scale grid architectures to potentially smaller networks. And I remember giving a sort of keynote speech like this about 10 years ago, presenting a notion of back to the future. Back in the 1920s in London, there were 15 supply voltages in the city, 12 different frequencies, all operating over different machines. The cables were being laid in the gutters. I think the health and safety executive might have a wee problem with that. The idea of having a walk home from a nice meal at night could have been a whole electrifying experience. And you would have no need for a taxi as you took off at 100 miles an hour. That having been said, we've got an opportunity now, absolutely now, the next 5 years are going to be critical, to redefine in Europe and the United States what a grid for the 21st century looks like, and what technologies we use, and what base equipment needs to go in there. So again, this is a big issue, a big opportunity. But what are the challenges? If I just point out to you here from a Scottish perspective, here at the moment, this is the 275 kV transmission system up here from Dounreay all the way across here to Peterhead, Aberdeen, through Dundee and the likes, and a little trail up here into the hydros here in Argyll. And then you've got the two major interconnectors at 400 kV between Scotland and England. But now, Beauly Denny is going to be appearing down here over the next couple of years. However, note that the majority of the sites, and if you remember the colour diagram I gave you in terms of where the resource was, in terms of offshore wind and marine, by and large, but simply put, most of the resources where the grid isn't. So there's a big issue there in terms of how we capitalise on this. And of course, some of the challenges of the public inquiry around Beauly Denny gives us some of the societal trade-offs that we need to be thinking about now. And also the cost, because that 170 miles worth of line is going to cost about £400 million. And when we think about that, just as a small section of transmission system, comfortably, if we're going to be rewiring Scotland and potentially subsea grid, which I'll say something about in a moment, we're probably talking about something north of £10 billion of network investment over the next decade, if we're going to be replacing existing assets and capitalising on the renewable resource. But again, putting it into context, peak demand in Scotland about 6 gigawatts. There are about 17 gigawatts or so of onshore applications. Of course, not all will proceed. And then we come back to the bottleneck problem, because the HV interconnectors, that's these 400 kV lines here, have a transfer capacity of about 3 gigawatts. So we've got peak demand. The arithmetic is very simple. 6 gigawatt peak demand, 3 gigawatts transfer, and potentially 25 gigawatts of power. So we don't have the transmission capacity to allow us to capitalise, to secure our own supplies and give us a commercial value to be a green powerhouse for Europe. So this whole idea of grid is upon us, and we need to have a major look at this. So let's think about what we can be doing here. So need for network evolution. The way that the grid has evolved internationally over the past 80 years or so has been this rather radial approach, where we have large centralised stations going out to industrial, commercial and ultimately domestic load. The whole idea of the European smart grid, this logo is a major initiative that we're involved in through the ETP. Strathclyde's leading on this one with Europe. Is the smart grid technology where, with the powers of clip art, it means that we're going from that sort of radial arrangement to something that's very much more interconnected and potentially autonomous. So the idea, which is anathema to electrical power network operators and the utilities, is that we don't have a big interconnected grid. We could have hundreds of small autonomous grids, that using power electronics and advanced control can reconfigure and reconnect and basically modify itself to optimise its security and also to capitalise on the available generation, whether it's in terms of it's available, or where's the lowest carbon generation available at the moment, or how do we want to supply back into the grid. So this simple bit of clip art hides quite a lot of technical challenge. And then if we go offshore, and we're really going to have to think about this, we've got substations basically in the sea. They'll be up on platforms here, and basically subsea cables here, potentially high voltage DC, not necessarily AC, taking the power back ashore. And here's a photograph of the Horns Rev in Denmark. Now what's that? 2, 4, 6, 8, 10, about 100-ish turbines with, I think that it uses an ABB technology. I think it's HVDC light. Regardless of that, it's a DC connection back ashore. And you're starting to see the scale of these things. And that will be about 250 megawatts, which is about a sixth of Longannet. So you're again, sense of scale, sense of the need for investment, but nonetheless something that that industry is building up. Beatrice's offshore wind farm, I'll say not too much more about. There's the northeast coast of Scotland, and up here we were putting a major connection in here which would be capable of taking a gigawatt of offshore wind ashore. One of the problems is once it came ashore here at Nig, the transmission system up around about here only had about 300 megawatts, has only about 300 megawatts of spare capacity. So you're back to the balance between potential and the reality of being able to carry this forward. And again, I just like Beatrice. I put another photograph in there. It's quite a nice blue sky and big turbine. That's quite nice. Electricity, which is now part of Scottish and Southern Energy, started to put the words in place about European supergrid. And you can see here again, it's a bit of simple clip art about the potential now to connect Scotland to Ireland in a fuller way, connect down to the south of England. Up here, you can see HVDC connections potentially in the west coast of Ireland, and all around here in the space between us and Scandinavia. And there's a genuine now push in the part of Germany and France to try and create this. What's interesting for me, and in Dubai and Abu Dhabi are now lining up some very significant investment. The prospect here is if we can get this European supergrid to take us down here and we start going into the Mediterranean, the same concept is just literally a hop to go from there to North Africa. And once we're in North Africa, the opportunity to connect all the way down into the Gulf states is being modelled. So this whole idea about complex networks, very interesting control and dynamic stability issues, is driving some of the thinking. And just the way that we are conceived of the gridiron of electrical energy in Scotland, in the UK in 26, people are now genuinely pressing the idea of a Richard Smalley. I don't know if Richard Smalley was one of the inventors of the buckyball, and he came up with some nanofibers, and he had this idea of a world grid, which was I thought was absolutely mad when I first heard them talking about it. But we're now actually starting to see these concepts emerging. So this idea of biological science, which is starting to get these very strange interactions in complex systems. So the mathematicians and some of the physicists are getting excited about what a European supergrid might actually behave like, and some of the strange behaviours that might emerge. But I'm getting excited, so I've got a lot more to tell you about it. So let me just also mention to you, here is real prospects of east and west coast subsea grid that's emerging, and this is not a research concept. The UK Electricity Network Strategy Group, which reports directly to Ed Miliband at BER, are now lining up new regulatory regimes, new grid codes and potential regulatory allowances for investment. And Geoffrey, you would have seen some of this coming through in CST as recently as about a year and a half ago, that these subsea grid propositions are likely to emerge pretty quickly. So a quick run through before I have another 20 minutes, and I've got some key things I want to leave you with. In the ETP, bioenergy is starting to give us a real opportunity now to work with our colleagues in biological sciences. The built environment and demand side, can't say enough about. I'll mention this in the passing before I conclude. But the whole idea of demand reduction, more effective use of energy, new materials, new ways of living, the whole idea about sustainable architecture. Again, we have a real opportunity here to coordinate our architecture, our architects, and indeed the science and engineering of this. Energy conversion and storage, the whole idea of, you see some ideas here coming out of St Andrews about micro or nano storage frameworks for hydrogen, right through to electrical vehicles. There's a big push here, and we need to be careful that we're not being overtaken by the automotive industry, but nonetheless there's some basic science and materials propositions that we can push forward. Oil and gas, again, I'll simply flag up, let's not forget them. Oil and gas are at pains to remind us all the time that they are a very important part of the picture, and Sir Ian Wood and Malcolm Webb sit on the Scottish Energy Advisory Board, and they are constructively vocal about reminding us that oil and gas has quite a lot to offer for the foreseeable future. I'll also mention, Geoffrey, and I don't quite have all the slides that I would have liked from Stefano and Stuart, other than to say the opportunity now for us to lead on demonstration projects, to go from the high quality research and development in our university labs, particularly at Edinburgh, through to deployment, I hope, on Lunganet coal station, and prospectively, if EU go ahead for another trial, prospectively carbon capture on one of the first gas stations at Peterhead, means that we can really push here to try and capitalise on our know-how. But the potential now to build an industry in Scotland around this is significant, and I'm told a conservative estimate of the number of CCS jobs in Scotland over the next decade is around 10 to 15,000. That's core jobs in the technology and the manufacturing, but also the supply chain. So a prize worth having. And the last thing I'm going to say more generally is that the pools, and many of you from the academic sector know about this, but the pools are working in a much more collegiate way, insofar as Leslie Yellowlees of Edinburgh, chemist, is, with my support, has just become convener of the pooling directorate. And I think next month we're having our first meeting looking at super pooling issues. And energy and climate change is just a great area for us to be trying to concentrate our physicists. They've just appointed a director in Super that's going to take on the energy challenge in particular, not just nuclear, but nuclear is going to be in there. SALSA, through, again, not exclusively, particularly synthetic biology, the engineering pool, informatics, because we're going to have smart grid, we're going to have important communications infrastructures, and computational intelligence, the energy technology partnership itself, but economics, marine science, chemistry, and last but not least, SAGES, and others will emerge. So here's an opportunity for Scotland to get the multiplier on pooling and to get the cohesion across our institutions and tackle big global issues in a multidisciplinary way. I genuinely believe this is an opportunity that Scotland's well placed to take advantage of. So, a lot of that was supply side, it's a big part demand side in terms of fuels, sources and infrastructure, but just as important is supply side. And just too busy a slide, I do beg your pardon. Let me just capture the essence of this. So, for example, that bit of a twee line, bringing rocket science to the building system, that's a line that the Building Research Establishment is using just now, with this idea of prospectively poor performance of building systems in modern buildings means that there's real significant waste in energy, not just direct loss, but in terms of how we might manage and model and have real-time control of energy usage. The BRE, Building Research Establishment Centre, is looking at taking advanced non-linear control techniques, as it happens, out of the aerospace domain and trying to get much smarter use of energy-consuming devices. And notwithstanding that, we need to remember the actual physical design and the materials that are used. But nonetheless, the whole idea of putting much more digital design at the front end to allow us to test and assess the feasibility of certain design is important, but more importantly, and this is an area that's been around for many years in terms of energy management systems, but in terms of pervasive communications, much smarter control, and a will, I think, increasingly from the policymakers around building standards, although we may talk about that in the Q&A. There'll be one or two folk in here who know quite a lot about where we are in the building standards. If we actually were a bit more demanding of the builders, notwithstanding that there are additional costs to be incurred, but if we were a bit more demanding and ambitious about the types of spaces we're building for our domestic sector as well as for the commercial sector, we might move forward. And again, another busy slide, and I do apologise. One concept I think is really exciting that I've become aware of in the past 6 months, and this is this idea of power distribution over the Ethernet. So, for example, take a little vignette here where we've got low-carbon grid power. Let's say it's coming in from all of the wind and wave energy that we've captured, and distributed renewable energy resources on and around buildings, taken in through here through basically, for shorthand, an electrical collector. The power can actually be distributed through low-voltage DC onto the Ethernet, so no need for a 240-volt cable, no need for rather energy-hungry DC-AC inverters and converters, which produce losses of about 30%. So the power over Ethernet, I think I would say to you, is going to be one of the next revolutions over the next decade, where power supply will be through the IT infrastructure. Now, we're not going to get kilowatts or megawatts out, but we can get quite high levels of power sufficient to be driving those devices with natural battery energy storage, be it PCs, other office devices, TVs, whatever. So power over Ethernet, have a look at that, and I think, again, that's another convergence in our electronics, communications and building designers, and it's maybe of interest to you that work that we're doing with the Building Research Establishment. Siemens is now moving towards some prototype products, and the Welsh Assembly, who want to be seen to be socially responsible, are looking for a deployment actually in the Welsh Assembly itself, and looking at schools for the future, where all the IT provision, I shouldn't say that, prospectively, some of the IT provision in Welsh schools will be done by provision of power over the Ethernet. And I was mentioning to Stuart Monroe, given the ECRR piece, I wanted to make sure there was a rural reference here somewhere, not only what we're doing here. And the term wind crofting emerged from a dear friend of mine, a man called Gordon Provan. He's not terribly well just now, but he runs a company called Provan Engineering, makes wind turbines up to about 15 to 20 kilowatts. And this idea of wind crofting is being realised or facilitated by DC networks as it happens. So it's this idea of harvesting the wind, maybe having a rural community, and you see the potential here, I'm sure, in your own local communities, where there might be a set of distributed 5 to 10 kilowatt wind turbines and over several thousand acres. We could be thinking about putting fairly low-cost DC network connections between each farms and some homes, and connecting to a single grid interface, a potential for commercial value. So not only providing the farm with its local green energy provision or in the home, but from a commercial, as it were, collective, as it were, in that crofting sense, then selling back surplus energy back into the grid. And I believe there's some real interest in this, and Gordon Provan should be credited with this, but one of the real facilitators here is the nature of the low-cost, flexible electrical networks that allow us to get there. Another project that's important, because we've talked about large companies, large infrastructure, it's important for us as citizens to engage with this challenge. And one project that I'm quite significantly involved in, it's still promising. It's not delivered a major outcome yet, but it's getting there. It's a prospect that we took to, as it happened, Stephen Purcell and the leaders of the Glasgow City Council about 2 years ago, about sustainability. And Glasgow has a very significant socio-economic problem in parts of the city, as you'll be well aware of, not least of which the East End of Glasgow. And not just because of the Commonwealth Games, but the trigger of the Commonwealth Games meant that we looked at the potential for regeneration in the East End of Glasgow. And there was this idea of affordable, sustainable, low-carbon housing. I mean, again, with absolute respect to the city, a lot of it was rhetoric, and they were well-intended, but they didn't figure out how they were going to get from where they are now to where they would like them to be. So About a year, 15 months ago, we got Scottish and Southern Energy, a company called Veolia, a very big French-owned company, ourselves in Glasgow City, to start thinking about what the potential was in Glasgow. And when you think about this in terms of sustainability, I mean, in cities, half of the world's population live in cities, and I know, Stuart, this is about rural references, but certainly the other half must live in non-city environments by definition. But cities are responsible for 75% of the world's energy consumption and 80% of the world's greenhouse gases. So we can see, just the, I think that might be Buchanan Street. Is it? Yes, I think it is Buchanan Street. You get the idea of the intensity, and I'll show you some slides which that make you think here as well. But the vision of this project, and I think in one or two you managed to go to the launch about 4 weeks ago. We're now trying to push towards what's promising to be £1.5 billion worth of investment in Glasgow. None of the money will be in the city. It'll be coming from private and public funds outside the city, but prospectively transform it. And it's the idea of making Glasgow one of Europe's most sustainable cities within 10 years. We had, at the opening of 3 or 4 weeks ago, Joel Shiraga, who's the policy director at the American Environmental Protection Agency, EPA. And he was very complimentary about the project, and he was saying that it's the first time he's seen, one of the few times that he's seen a city not only talking about this, but trying to get a plan that will start to deliver some of it. So, given the health and economic and social issues in Glasgow, it's got to be about direct impact for Glasgow's people and also social enterprise. Looking for Glasgow to be a leader in sustainable urban living, and also, and with support from the Scottish Government, because Jim Mather 4 weeks ago announced an allowance of about £250,000 from the Central Energy Efficiency Fund. We want to see if we can get this right in Glasgow. Edinburgh, I should say to you, and I don't know if many colleagues here today have been expressing an interest in getting some of the templates and modelling methods that have been used to get this far. So that's encouraging, and it shows you the cooperation that's there. But the carbon footprint in 2006-2007 looked a bit like this in Glasgow in terms of tonnes, about 4 million tonnes per annum. Biggest culprits here: domestic electricity, domestic gas, industrial electricity use. But you can see the rest coming in terms of transport, road freight and buses. But a big part to play there in terms of trying to reducing carbon around the electrical energy supply, although transportation itself is very important. This, we actually worked with DBER to try and get some mapping of the carbon emissions density. And you can see these dark colours are talking about 30 to 100 kilograms of CO2 per square metre. And that, as it happens, is right where the Glasgow City Chambers are, right where Strathclyde University is, which was disappointing for me. But it's starting to map out where we can start to concentrate the greening or the decarbonisation strategies in and around the city. And the east end of Glasgow as well, it comes in and around here where we can start to concentrate our activities. So projects that are now emerging, and now we have a real big take-up from industrial engagement. Because remember, it's about research ideas, policy engagement by the city, but then investment and risk-taking has to follow to realise the difference. So we now have Scottish Power, Scottish Water, SPT, I think, is in there, and a number of other big industrials are now saying, well, what about going in here? This slatted area is talking about district heating, something that Scandinavians are good at. They're good at in Germany. Freiburg, for example, is a model city where green energy and things like district heating play a part. So it's about putting in the infrastructure where we could have combined heat and power stations, but then what was maybe 40 or 50 years ago seen as very ugly piping that takes the exhaust steam and the control steam into houses and into the commercial and industrial properties. So this is not clip art, colleagues. These are projects that the industrial partners are now saying they are prepared to invest in. Notwithstanding there's a negotiation around how they're going to get a return on investment over the next 25 to 30 years, but nonetheless it's there. The idea of putting in woodlands in terms of carbon capture naturally, waste transfer solutions as well. Again, looking at new ways of bioremediation and capture in and around the city. So there's, if you excuse the pun, there's real energy building up around this project, and the whole idea of getting an integrated low carbon energy system should be good for Glasgow if it goes ahead. Could become a bit of a template that will raise Scotland's game, where we combine heat and power with low transport for low carbon supply for electrical transport. We're talking about the usual suspect of anaerobic digestion and biomass plant. But the fact that the city is thinking about this, I think, is a step forward. And the estimated carbon reductions, if we get those projects that you've just seen, are significant. And will be the order of 0.5 to 1 million tonnes of carbon a year. So it's good. We hope it will create jobs. It will certainly attract investment, and more importantly, I think it will give Glasgow an opportunity to be distinct. 2 horribly busy slides, and I do apologise. I'd said to Stuart when we talked about this lecture a few months ago that I hope to be making some references to Copenhagen, and I hope that we'd all be standing here saying what a fantastic week or 2 that was, and look at all the great outcomes that emerged from it, and in which case that would have been full of clip art of politicians slapping each other in the back. However, what we do know is that there was no binding treaty, because the point I was trying to make moving in here is that it's certainly about acting locally, and it's about being ambitious and setting government targets and getting the technologies and the policies to work. But we'll have to see ourselves in the international context. And I think everyone will see that it was rather a disappointing conclusion in Copenhagen, because we didn't really get this carbon emissions reduction agreed on a national, subnational actions. Nonetheless, I hope it's a chapter in a longer story. The emissions in developing economies will continue to rise, and we know the stories about China and India. Of course, they naturally are trying to grow economies and tackle poverty and increase their own economic and political influence. Of course, our behaviours and our regulatory approaches is accelerating the growth in carbon emissions over there, and of course the fundamental Copenhagen proposal about richer countries paying to fund carbon reduction in poorer countries is ethically correct. But then back home, particularly in recession, what do the citizens of the richer countries, so-called these days, think about a regular commitment of very major funding to allow these other economies to develop in a way that's more sustainable? Sums have been agreed by the EU, Japan and US, will create huge growth in low carbon industry in the developing world, and it's this terrible interaction between investment and the need for economic growth. But nonetheless, there may be opportunities for joint ventures. Again, I'm conscious of the time, I'm conscious of the number of words on this. Suffice to say, disappointment, but something that we need to stay on track with. And I'm going to amaze myself, Stuart and Jeffrey, by staying on time with a summary slide. And a couple of summary comments from me. Well, let's take the Scottish perspective. I think that's important, and we shouldn't be afraid to do that. We generally have real strong capabilities and assets and skills in oil and gas, conventional power generation, nuclear and grid. And I haven't said a lot about nuclear, and I apologise for that. I realise I should have done, so let me just take one moment. I believe that nuclear is an important part of our energy future. Where we are currently in the consideration of the Scottish Government is that that's not, there's going to be no new nuclear build anytime soon with the current Scottish administration, but we have nuclear power, of course, in Hunterston and Torness. I think what I am encouraging we have done, and the ETP hopes to play a full part in this, is that as independent academics, and there are many folk here in the room that would recognise this, I think the ETP are going to offer, whether or not the offer is taken up is another matter, the development of an evidence base that's based on sound scenarios. Some of them may be radical, but I think all of them prospective futures, and try and understand entirely what it means to have no nuclear, some nuclear, a lot of nuclear, in the context of where Scotland's going in terms of capitalising on its renewable potential, but also understanding that if we were to create this European supergrid or beyond, then the pressure points on where and how energy is delivered, it starts to relax a little bit, although the morality of government policy and the ethical approach to getting collaborative strategies in place will always be there. But I think nuclear should be considered as part of our future. It's interesting, and some of you will know this, Scottish Power and Scottish and Southern Energy have just created a joint venture, and they've just bought land just in Cumbria to prospectively build or be involved in building a nuclear power station. It would be good in terms of low carbon technologies, security of supply, job and wealth creation, if we were to consider this seriously around an evidence base, so that we are taking the responsibility for informing our political leaders and hopefully allowing them to make decisions that are based on good data and good independent science. But I'll say no more than that. We may discuss it in a moment. Anyway, so the base that we're talking about is nuclear grid, conventional power, renewables. I'll say about skills in a moment. Great resources, strong and growing renewable, low carbon energy industry sector, and that's good, but we're not a one-horse race. Most of the rest of the world are looking at this as well. I will take a moment to do a small advertisement for universities and colleges and the likes, but significant opportunity to realise the commercial value and policy targets by getting genuine partnership. And I know this is the moment we'll hold hands and sing Kumbaya. However, bringing government leaders, bringing private and public sector partners together, and indeed the innovators and educators and researchers in universities and colleges, fundamental. And we're big enough to be significant in Scotland and small enough to be practical at realising this. And we should be looking about developing new skills for the renewables industry. Geoffrey and I attended, along with one or two of you, the National Economic Forum, that was my first one, Geoffrey, and I was told it was actually constructive. So Geoffrey and I in particular were beating a drum about really trying to use this energy opportunity for Scotland, renewables and other things, to act as a springboard to promote engineering and science to our young people and have them drive in here. Skills Development Scotland are currently modelling what a skills action plan would look like to create or be ready to supply up to about 200,000 jobs into new energy industries. Very significant for Scotland's economy, but we need to continue to attract investment, and that means the supply chain, and also means making sure that our research and innovation continues to be invested in. There was Anne was particularly involved in, let me make sure I get the report right, and it was about Scotland's position in the international science scene in terms of us punching above our weight, as it were. I think Mr. Salmond was involved in launching that. That's only true if we continue to value and invest what we do in higher education and in colleges. That's a major differentiator. Where we are in the public sector funding just now means that's tough at the moment, but recognising that as a key Scottish differentiator is a great starting point. So offering international business, investment opportunities and partnering potential, super. Through my involvement with Scottish Enterprise, I'm genuinely seeing a big international attraction into Scotland just now. Long may that continue, but if we don't welcome them, they'll go somewhere else. And we do have to have a much better approach to integrating planning, regulation and investment. And the last point I would make is we need to act now. The opportunity is not going to be here forever. So here's the opportunity. Let's make sure we capitalise on it. Thank you very much.
Thank you very much, Jim. My name is Stuart Monroe. I'm the Scientific Director of ECRR, so it's part of the partnership which is here tonight that's put on this performance, which has been an absolutely magnificent one. We kept referring to, what's rural, and what's rural has been regarded often as what isn't urban. But here tonight we've got urban and rural coming together, and I think that interaction has been quite important. We've got a little bit of time for some questions, and can I ask you to preferably be quite brief, short in your questions, sharp and to the point, and if you can also wait until one of the microphones comes to you, then we'll be all aware of what you're about to say. The one at the back, to kick us off.
Sorry if this is a very basic question, but you showed a picture of a blade of a turbine. I just wonder why they're so thin. You'd think if they were wider, they'd they'd have a greater surface energy and collect more wind and be more efficient?
Design of blades, by the way, is a major challenge, and it's a mixture of the mechanical and structural integrity that we require to withstand some of the gusting. So material science, the idea of potentially going beyond composites to fairly radical material propositions is key. There are a number of prototype blades which are radically different from what you might call these conventional designs, and because of this horizontally mounted arrangement and this vertically rotating three-bladed system, there are some just direct aerodynamic limits in terms of how we can extract energy safely. I will give you a little hint. There are some very unusual designs. In fact, Duncan Michael was speaking to a friend of mine in China just about a month ago, a mutual friend in Hopewell Industries, that are looking at wind turbines that are maybe 400 megawatts. And so I told you the biggest one that's been aimed at just now is this conventional design, up to 10 megawatts. If we go back to a vertical axis and a whole arrangement of different blading designs, then prospectively there's an enormous opportunity to get beyond the limit of the materials and the aerodynamic and control problems. But radical designs are coming, but they're high risk and they're potentially game-changing. But to your point, materials, aerodynamics and controllability, and some of the real, you have to design for some of the major wind gusts that are likely to be impinging on the blades themselves. But the point is good. Blade design must continue. To even get another 5-10% efficiency can make a big difference on the effectiveness of a wind farm.
There's one day at the front here.
What's the situation on the I think it's an oil burner, Inverkip? You never mentioned it in your on your map.
The oil burner.
I think it's an oil burner. The oil power station at Inverkip.
Even Inverkip station itself?
Yeah.
I was on the commissioning team at Inverkip, and the last time I wore a snowy white overall and a white helmet when Sir Donald Miller came round to open it. And I remember as a young engineer I was thrust out to stand to attention in front of him. Inverkip was designed to be the sister station to Peterhead, and it was ahead of the Peterhead design by about 4 or 5 years, and it was going to burn oil. If you remember, it was at the time when Anthony Wedgwood Bend was Energy Minister, and Inverkip boilers were designed, and the combustion systems were designed around oil. And then the oil crisis happened, and Inverkip has basically been stripped back now, so there is no power station there. Just ahead of that, and just in time for it to be not too late, the boiler design at Peterhead changed. It was an El Paso design that was put into Inverkip, which allowed it to burn oil and gas. If you remember, bringing on the gas from offshore allowed Peterhead to go ahead without being basically mothballed, as what happened in Inverkip. Tragedy, it ran at its most intense levels through the coal strikes in 83, 85, and that was a weapon that the UK government had at the time to make sure that we didn't run down coal stocks. So Inverkip, it's not really been running for the best part of 16, 17 years. And it's stripped now. So all the electrical generator parts have been used as spares for Hunterston and the likes.
We've got a few questions. A question up at the back there.
Could I go back to near the beginning of your lecture when you talked about energy conversion and storage?
Yes.
Because wind installations deliver their power about 30% of the time, it's highly intermittent and unpredictable. Yeah. And there's a serious mismatch between production and usage, which varies on a diurnal basis, on a monthly basis, seasonal basis. It seems to me that we need energy storage on a big scale. Yeah. And you hardly mentioned this at all. Could you say something more about how we're going to tackle that problem?
Thank you for that. Just a quick comment on that. The intermittency issues are not entirely insurmountable, and in terms of the scale of, let's say we had 20, 30 of these large-scale 300 to 600 megawatt farms, the idea of predictability is not out of the question. So, for example, the offshore wind deployments, I think, can be scheduled with reasonable certainty. Now, you're not necessarily going to say a 500 megawatt offshore wind farm is going to be fully available all of the time, but you can schedule and predict, and in a short-term prediction, forecasting is a lot easier when you're forecasting a few minutes ahead as opposed to a few days ahead, I accept. But even current wind farms use LiDAR technology just for predicting onset and wave fronts to try and optimise the wind farm. But to your point, just as I was mentioning, power electronics was a game-changing technology in grid technology, in grid design and grid operation. Storage is absolutely a game-changing technology. If you remember, there was a ultimately unsuccessful attempt at commercialising a large electrochemical storage solution called Regenesis. National Grid spun this out, and it was talking about storing gigawatt hours of energy on the grid. So for me, yes, storage is absolutely important. What's coming around the corner? Well, there's lots of smaller scale solutions like superconducting magnetic energy storage, the whole idea of potentially compressed gases into things like disused mine shafts. A bit fanciful, but perspective there. But the electrochemistry, I think, could be a solution. Is it coming anytime soon? Large scale, no. Small scale, potentially, yes. So some of the work that we're doing in and around battery technologies, very important. Colleagues, as I mentioned before, at St Andrews, very effective battery technologies. We could be good for distributed and microgrid applications. But if you get the aggregate on many thousands of microgrids, then you can get the offset on the intermittency. So there have been. I just want to come back to the intermittency thing for a moment. I mean, we've been involved with colleagues at Imperial and the Applied Economics Department at Cambridge on just what the value is or what the cost might be of intermittency. I would point you to the DBER site, and you'll get some publicly available reports. It's not as problematic as one might imagine, but I would agree with you, sir, because I think I know what your assertion is here. For me, dispatchable technology, baseload plant is there to complement these renewable resources that we need to take advantage of. But for me, storage would be economically viable, and large-scale storage would be a game changer.
There's a one at the front there.
Hello. The European supergrids that are being talked about, what sort of capacity interconnectors would the UK have, north and south? Yeah. And is there scope for that to get over the intermittency issues altogether, if you're balancing through Northern Africa and so on?
I think it's a really good point. Just now I was mentioning the two existing interconnectors between Scotland and England, just under 3 gigawatts of capacity. The channel connection between England and France, about 2 to 3 gigawatts as well. The link over to Ireland, about 1 gigawatts. We need to be talking about orders of magnitude higher capacity exchange between Scotland and either the rest of the UK or the rest of Europe. So for me, the intermittency issue, it's when you start to talk about the systems issue, just now, intermittency in a small system like Scotland, for example, if we were isolated, becomes a major issue. If you start talking about the sharing of dispatchable resources and intermittent resources, and the diversity of having microgrids, the potential for a European power system starts to alleviate some of the direct pressures of these intermittencies. So the whole notion of complexity and the controllability starts to be a problem. But it's a problem that can be solved. I'm pretty confident with that in terms of comms and control. But intermittency is a big issue when you're entirely dependent on intermittent sources. But it starts to become moderated in a bigger construct like a European power system.
The gentleman standing has been wanting to get in for a wee while.
Hi, you had a map showing earlier some of the interconnectors between, for example, Aberdeen and Norway and quite a few other long links. I admire the enthusiasm, but how can we afford these when we appear not to be able to save the Bewley to Denny and Drummochter high voltage power lines?
Well, how do we afford it? It's for Scotland, the £10 billion question. Ofgem published, for me, a surprising report about 2 weeks ago that's now suggesting that we might have to consider renationalising. They didn't use all of those words, but in effect, renationalising the grid. Just now, one of the big arguments about is who pays and how do you get a return on the investment. And rough numbers just now about allowing National Grid and Scottish Power to invest in subsea grid would mean they'd need something like a 10% ROI to make it worth a while and get those regulated returns on investment. I think it's still a tough call, but in terms of people looking for a less risky investment, large-scale energy infrastructure is attracting more of the world's investment than it's ever done. Than it has done for many decades. But when you start hearing Ofgem, which is full of economists, I don't think that's a bad thing. They've got less technical people than they should have. In fact, the last sensible guy in there was a guy called John Scott, who now works for Kima Consulting. He was a good electrical engineer. But when you hear Ofgem hypothesising about the need to have government control over network growth and infrastructure, for me, immediately I thought, well, could this be the potential Weir Act 1926 equivalent now? But there's a big political problem with that one. But if Ofgem are talking about it, you know that we're going to have troubles getting the investment.
Got a question down here.
Yes. Given the vulnerability of many of the facilities you've been talking about, what are the arrangements for their protection, A? And B, how does the Scottish Parliament's committee system cope with the discussions about the things you've been talking about?
Okay, just to be sure I'm going to respond properly, are you thinking about the physical security against attack? Okay, during the Troubles in Ireland, it was almost the equivalent of the Forth Road Bridge painting. You painted it to one end and it was time to go back and start painting it again. The grid connection between Northern and Southern Ireland was just a perfect terrorist target, and very often pylons would be blown up, substations would be attacked, and no sooner would Electricity Supply Board Ireland or Northern Ireland Electric rebuild it, then bang, it would come back down again. So let's not kid ourselves. Big physical bits of infrastructure are targets, or prospective targets. Should that stop us building it? No. There are political issues there in terms of the responsibility we have to our citizens in terms of supplying secure, low-carbon, affordable supplies. So there are vulnerabilities there. There are no two ways about it. But with any major infrastructure investment comes the responsibility to protect it. So, these are considered. There are other colleagues that are in the room that have been involved in advising Westminster Government. I have been involved in these things as well, as to how you try and make these things resilient, and grid interconnection and the ability to, for example, that proposition I made to you about smart grid, where you can automatically and intelligently reconfigure the network in response to major events. Now, a major event might be a storm where part of a transmission line comes down. It'd be terrible to think of it, but another major event might be a cynical attack on a substation. But if we've got a reconfigurable distributed approach to smart grid technology, then we protect ourselves. To the point on the Scottish Government approach, well, they have their standing committee for energy, economy and tourism, which was an interesting grouping. But they consult regularly, to be fair to them. I mean, Geoffrey, on behalf of the RSE, and I think you had my friend Muldoon acting to support you, arranged probably about 3 tutorial sessions with that committee through 2008, 2009, where they genuinely took sort of 2-hour meetings that was really the RSE were brokering, a group of people to go and talk about grid, renewables. We never got to talk about nuclear, I seem to remember, but renewables, grid, demand-side management. So they listen. And just about 9 months ago, Mr. Salmon set up the Energy Advisory Board, which was interesting for me because he has very influential people in there, and now I hope he's listening to them. And I'm not talking about me in that case. He's got Ian Wood, Ian Marchant, Ian Wood from the Wood Group, Ian Marchant, Chief Executive of Scottish and Southern, Nick Horler, Chief Executive of Scottish Power, Jim McCall. So these are not patsies. So they're there to give an opinion. Whether or not our government listen to it is another matter, but at least the channels to influence and channels to advice are there. So, but I can't speak to how attentive they are, but they're hearing things.
I'm really sorry. The hands are going up left, right, and centre now, and there's a whole lot of questions that are coming from the floor. But I'm afraid we've got to call it a day there. I think the best time to conclude a meeting like this is when there is still that buzz and excitement coming from the questions from the floor. So can I now just ask Nicky Suter on behalf of the Society for Biology to propose a vote of thanks. Nicky.
Thank you, Stuart. Mr. Chairman, introducing myself, Nicky Suter, Society of Biology. I'm also one of his workers, so when I asked Jim earlier this evening how I should start the vote of thanks, he said, "Your Supreme Excellence," or something of that nature. It's perhaps dangerous to give a biologist the opportunity to speak once an engineer has finished, but putting temptations on the side, I think the talk this evening has covered everything that we would have hoped for in such a presentation. It was interesting, it was entertaining, it was challenging, and it has certainly provoked discussion, which perhaps will go on, and indeed should go on. Some of my friends in education regard science educators as people who work in metaphors. I think Jim provided his own series of metaphors this evening. He spoke about energy. That was the title. Current is something to do with energy, I understand, and he illustrated that with tidal waves. In fact, it seemed at one point that there was a tsunami coming when he said, "I'll just accelerate." The alternative approaches into meeting the energy demands of Scotland, of Europe, and beyond, it seemed that there was an almost energy empire that was stretching out into the Mediterranean, into Africa, into the Gulf, and beyond. What an exciting prospect! What a enthusiasm you gave in the presentation tonight. The direct way in which he addressed each one of us, I thought it was a very personal approach, and I gauged from the questions that each one of us had received that sort of message, which did something to provoke our own thinking. He relayed messages that will go beyond this room this evening, and hopefully will inform, and indeed is informing the people who create the policies. Energy perhaps wasn't the best title. Energy, enthusiasm, electricity, a manifesto for Scotland. Jim, thank you very much indeed.